Let's talk about the standard input and output. We know them as standard in, standard out, and standard error. They are three file connections, and they're opened whenever a program starts up. Now, this all of this applies in DOS and Linux, Unix variants. So we're all talking on the same page here, even though there's different operating systems involved. stdin is the name of a file connection that's created as standard input. If you run a program and don't do any redirection, pipelining, or less thans, or anything like that, the standard input is typically the keyboard. The standard output will typically be the screen, out to the screen. If you do redirection, or you pipe the output of a program into another program, the standard output will be redirected by the operating system, not by the program. The program that's running has no idea where it's getting its input from or where the output is going. That's the beauty of standard in and standard out. Now, standard error is just like standard out. It's attached to the screen, the typical output, but standard error cannot be redirected. What you would have to do to get your standard error output to a log or some other place is close and reopen the standard error connection, which is not typically done. It's not typically done to move that error output because a lot of operating systems and other systems depend on standard error to do its job. And your program will generally leave standard error alone and use it if it needs to. Like I said, command line redirection does affect standard in and standard out, but not error. Put care that we've used already uses standard out, and get care gets its characters from standard in. Pretty simple. So let's take a look at a little piece of code here and how it works and how some of this stuff happens. Here's there's our lower.c. Here's our little program. Let me get some of this stuff out of the way back here. There we go. That's a little nicer. Here's our program, pound include standard IO. Got to have that one because that's what we're dealing with now is our standard IO. So we got to pick up the header. We come in here, have a little character, and while C equals getChar. So getChar is going to take from the standard in, whatever that happens to be. So we're going to get that character into C. And as long as it's not end of file, and EOF, it's typically -1 is the value, but that depends on the operating system. EOF was defined up here in standardIO.h. So as long as the character that we read is not the end of file, then we will put that character back out with a toLower. And toLower is a standard library function that will lowercase uppercase letters and put them out in lowercase, and it will leave punctuation and things like that alone. Pretty basic. And then when we're all done with the while loop, there's no more characters. There are no more characters coming in. We just return 0. Okay, so that's our program. Now, let's come here and compile and link it. And it links. And if we run lower, just like this, it sits there waiting for input. And we can say this is mixed input. And it comes back in lowercase when I press a carriage return because it handles a line. It's buffered input. So each of the characters have to go in and a carriage return has to end the line. You can change that by making operating system control calls and say that you don't want buffered input so that every character comes in one after the other, but that's not what we're dealing with here. So there's an example of using lower, just reading from standard in, hooked to the keyboard, standard out, is going to the screen. Pretty typical. Normal startup. Let's, though, have a file. I have a file out here. I'm going to type it out, and it's called uppercase.txt. And there you can see that uppercase.txt is just that. It's 2 or 3 sentences of information. It's all in uppercase. All right, so if we run our lower program and we take input from, we do the less than symbol, from uppercase.txt file, it will put that text out in lowercase because the standard in is now coming from this file. All right, does that make sense? This file of data became the input stream. It became standard in. And then when we hit the end of the file, that was EOF, and the while loop stopped. So the while loop read all of this, character by character, called the toLower, and then did the put care of text out to standard out, which was the screen. We didn't redirect standard out. All right, now if we do lower taking in input from our file, and then we'll redirect the output to another file. We'll call it lowercase.text. So we're running our lower program. We've redirected the standard input to be from uppercase.text, and we have redirected the standard output to be lowercase.text. That's sometimes read as a giving lowercase.text. Now we got nothing to the screen. Had there been an error and we had used standard error or said something using an error routine, standard error could have still said something to the screen because stderr is still not redirected. It's not easily redirected. So now we should have a file called lowercase.text. And if we type it out, there it is. This text is written entirely in uppercase. Well, not anymore, because now it's lowercase text. That is the output of our lower program. Okay, does that make sense? Standard in, standard out, and standard error. You don't have to do anything or say anything to use them. You just need to include the standard IO header so that putChar and all of these things are declared properly up there. And then getChar, putChar, printf that we've already used, scanf that we're going to see how to use, all of those will operate entirely with the standard in and standard out and standard error connections. Okay, let's get our screen back up here. And we can end on our slide the way we should. So that's standard input and output.